So what I did for my presentation was I did question number 2, which is the 2-second rule a valid rule? Uh, the car I used was a Ford F-150, and it had -8 meters per second squared as its acceleration. I used 20 miles per hour and 80 miles per hour as my examples, and here are my conversions here. I had 20 miles per hour converted into 1,609.34 meters in a mile, and in 1 hour there's 3,600 seconds, which made 8.94 meters per second. And I did the same thing for the 80 miles per hour here, just so I got that out of the way, which came out to 35.76 meters per second. Now, I started off using the 20 miles per hour. So the first step I did was, what is the distance while reacting? I multiplied the meters per second by the change in distance and my reaction time, which was 0.17 seconds. And I got 1.5 meters covered just from the reaction time. For the second one, this is my math for how much distance was covered while decelerating. I used the VF squared equation. After my math was done, I got 4.995 meters it took to stop while decelerating. For the third step, I had to find the distance between the cars, so I cross-multiplied the 8.94, which was the meters per second of 20 miles per hour, and I multiplied by 2 here, which is the 2 seconds between the cars. That came out to be 17.88 meters per second. So the next step was finding the total stopping distance. So I added the regular stopping distance of 4.995 meters plus 1.5, which is my reaction distance, to come out to 6.495 meters total. Distance between the cars was 17.88. 17.88 minus 6.495 means that after both cars are at a complete stop, it comes out to 11.385 meters between the cars. So I said there will be more than enough distance between the cars to stop safely. For trial number 2 is where I used the 80 miles per hour, which is the 35.76 meters per second. Reaction distance, again, I multiplied the 35.76, which is the 80 miles per hour in meters per second, by my reaction time, and I got 6.07 and just converted that to 6.1 meters covered. For step 2, once again, I'm finding out how long it'll take to stop distance-wise, and after all of my math, again, I used the VF squared equation, I came out to 79.92 meters. The third step was finding the distance between the cars. So again, I multiplied the meters per second by the 2 seconds between the cars and got 71.52 meters. For the fourth step, which is the total stopping distance, I did my reaction time distance covered, 6.1 meters, plus the 79.92, which was the regular stopping time, and got 86.02 meters. And the distance between the cars is 71.52 meters. So that means that it would not be safe to use the 2-second rule. So in conclusion, it would be safer to use the 2-second rule at a slower speed, but at a higher speed you would need a bigger distance between the cars for the 2-second rule to work.